See, in the last class, I proved a theorem based on areas of similar triangles. What is the statement of that particular theorem is, the ratios of areas of similar triangles, the ratio of areas of similar triangles is equal to square of the ratio of their corresponding sides. Based on that, there is an exercise that is 2.4 and having about 10 problems, and we are going to solve those problems in this class. The first problem of the exercise 2.4. The problems of this particular theorem is much easier when we compare the problems of Thales theorem or AAA similarity criteria. Very simple problems. See, the first problem is, let triangle ABC similar to triangle DEF. Means the triangles are similar. There is no need to prove triangles are similar. And their areas be respectively 64 square centimeter and 121 square centimeter. If EF is equal to 15.4 centimeter, find BC. This is the problem. Very simple problem. You can write the diagram, or without diagram also you can solve this particular problem. See, what is given is triangle ABC similar to triangle DEF. Triangle DEF. This is given. See how easy problems they are. Once you concentrate and understand one problem, remaining problem you can easily solve. Triangle ABC similar to triangle DEF means there are a lot of information embedded in this. Angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. Side AB and side DE are proportional. That is, AB by DE is equal to BC by EF is equal to AC by DF. That all we are able to understand. Therefore, since the triangles are similar, he only given that. Therefore, I can directly apply the theorem. The theorem tells that area of triangle ABC by area of triangle DEF is equal to the ratio of areas of similar triangles is equal to square of the ratios of their corresponding sides. Which are the corresponding sides? AB by DE. AB by DE square, or BC by EF. BC by EF whole square, or AC by DF, first letter and the last letter, whole square. Since these two triangles are similar, I can directly apply the theorem. Now what is given in the problem you have? See, let triangle ABC similar to triangle DEF and their areas be 64 and 121 square centimeter. If EF is equal to EF, I want EF. Where is that EF? EF is in the second ratio. Therefore, I select this one and this one. There is no need to write all the three. Right? Now, the second thing is area of triangle ABC by area of triangle DEF is equal to, I have selected EF. EF means BC by EF whole square. See, major part of the problem is over. Now we have to substitute the values given. What is given? Triangle ABC similar to triangle DEF and their areas be respectively 64 square centimeter. ABC is 64, I write here. ABC is 64. DEF is 121 equals EF is equal to 15.4. EF is in the denominator, this is 15.4. Find BC. BC is in the numerator. Whole square. See how simple. See, this is the relation of the theorem. Then substitution. Area of triangle ABC is 64, area of triangle EF is 121, the EF is equal to 15.4, we have to find the BC. Now skill, mathematical skill. These skills you should be very well versed with this type of skills because you are in 10th standard. See, what is the first step of the simplification technique? The first step is, here there is a square. If I wanted to remove the square here, I wanted to take the square root here. I can easily take the square root here because both the numbers are square numbers. Square root of 64 is 8. Square root of 121 is 11. These numbers, I think children, I wanted to tell you that square numbers, cube numbers, in the 10th standard level, you should be able to get it. See, square root of 64 is 8, square root of 121 is 11, that you have to understand. Here square is there, by taking roots on both sides, I take roots on both sides. See, what happens? 64 by 121 becomes 8 by 11. 8 by 11 is equal to BC by 15.4. What happened here? I removed the square, I taken the square root to that side. That is a simple approach. 8 by 11 is equal to BC by 15 by 0.4. The next step is cross multiplication. 11 into BC, 11 BC is equal to 8 into 15.4. 8 into 15.4, cross multiplication. This I got it by taking roots on both sides. Now BC is equal to 8 into 15.4 divided by 11. You are all in 10th standard, therefore you can easily simplify this. 11 ones are 11, 4 is left, then it becomes 44 or 4.4. This is equal to 1.4. 4.4 means 0.4. 11 into 0.4 is 4.4. Therefore, BC is equal to 8 into 1.4. That is the answer. You have to multiply and write. Multiplication of 8 into 1.4. 8 4s are 32. 3. 8 1s are 8 plus 3 is 11. There is a decimal point after one number, that is 11.2. What is the unit given? Centimeter. Therefore, this is centimeter. The length of BC is equal to 11.2 centimeter. I repeat the problem once again. See, this is a very simple problem. It's all problem of 2 marks. In this particular chapter, we are going to get one theorem of 4 marks. Therefore, there is no question of 4 marks you are going to get from this particular chapter. Therefore, you have to think about 2 marks and 3 marks questions in this chapter. This is 2 marks question. The problem is, there are 2 triangles ABC and DEF, they are similar and their areas are 64 and 121 square centimeter. One side EF is equal to 15.4, find BC, EF and BC are corresponding sides. We all know that when the triangles are similar, I can apply the theorem. The theorem tells that the ratio of areas of similar triangles is equal to squares of the ratio of their corresponding sides. I have written all the 3 sides. I picked BC by EF. Why? Because he is given the value of EF and he asked to find the value of BC. Therefore, this ratio and this one I selected. This is the selection part. Then this is the substitution part. Then here there is a skill, mathematical skill. Since here there is a square, to remove the square I have to take the square root on this side. It is easy to take square root on this side because these two are square numbers. 8 square is 64, 11 square is 120. Therefore, I remove that square, it becomes 8 by 11 is equal to BC by 15.4. Cross multiplication, I get 11 BC is equal to 8 into 15.4. BC is equal to 8 into 15.4 by 11. You know the table of 11 and by multiplication I got the length of BC is equal to 11.2 centimeter. Problem of the exercise. Very important problem. Many number of times this problem is repeated in the public examination. The problem is like this. Diagonals of a trapezium ABCD. Once I told you, in triangles, always they give the problem based on trapezium and parallelogram. By that, what is happening? It becomes an application type of problem, because out in the trapezium and parallelogram you have to identify the similar triangles. That is the idea of setting a question. Diagonals of a trapezium ABCD with AB parallel to DC intersect each other at the point O. If AB is equal to 2CD, AB and CD are parallel is given. AB is equal to 2CD, then obviously AB is bigger than CD. That you have to understand. That is a skill. AB is equal to 2CD, AB is parallel to DC, and it is a trapezium. Trapezium is a quadrilateral in which one pair of opposite sides are parallel. Here AB and DC are parallel, and AB is bigger than DC. AB is twice the length of the DC. That is the idea of this particular problem. And find the ratio of the areas of triangles AOB and COB. The skill of this particular problem is writing the diagram. Once you are able to write the diagram, then the problem is solved. See, I write the problem here. What it is, ABCD is a trapezium. First I write a trapezium. Trapezium is a quadrilateral in which one pair of opposite sides are parallel. These two are parallel. Now I wanted to name it. Can I name this as ABCD or ABCD? That is the idea. Here what is given is AB is 2CD. AB is bigger, CD is smaller. Therefore, this should be AB, this should be CD. Therefore, I write like this: A, B, C, D. If I write A, B, C, D like this, it becomes wrong. AB is twice the length of the CD. Therefore, this is twice the length of this. And AB is parallel to DC. AB is parallel to DC. It is a trapezium. Then what he told, diagonals of the trapezium ABCD with AB parallel to DC intersect each other at O. The diagonals has to meet at O. Right? They are meeting at O. Now, find the ratio of areas of the triangle AOB. Where is the AOB? You have to search. AOB is here. See, this is AOB. This is AOB. Another one is COD. COD is this. Now we have to find the ratio of the areas of AOB and COD. To find the ratio of AOB and COD, first step is we have to prove them these two triangles are similar using basics of geometry. Using the basics of geometry, you can prove that the triangles are similar. See, very simple it is. BC is parallel to AB, therefore angle A is equal to angle C. Angle A is equal to angle C. Why? Because these two are alternate angles, Z angles. These two lines are parallel and this is a transversal. Then angle O is equal to angle O. These two are vertically opposite angles. Then angle D is equal to angle B. These two are also what is known as alternate angles. Two alternate angles and one vertically opposite angle. See, I put in a color. A is equal to C, Y alternate angles. Angle O is equal to angle O, Y vertically opposite angles. Angle B is equal to angle B, Y, they are alternate angles. Therefore, the first step is I write like this. In a triangle, always I write according to their corresponding angles. Angle AO, in triangle AOB and triangle COD, angle A is equal to angle C, alternate angles. Angle O is equal to angle O, vertically opposite angles. Two angles are sufficient. There is no need for the finding the third angle, but it is easily available here. Therefore, we are writing that. Angle B is equal to angle D. That is also alternate angles. Therefore, triangle AOB similar to triangle COD by AAA. Three angles are mentioned, therefore AAA. Similarity criterion. AAA similarity. Nothing I did. Only thing is the trapezium you have to write. In a trapezium, one pair of opposite sides are parallel. Which one is bigger, which one is smaller? That is I given in the problem. I have to correctly name the trapezium. The diagonals intersect at O, and he only mentioned angle A, triangle AOD and triangle COD. These two triangles are similar, I wanted to prove, because he is not mentioned that these two triangles are similar. In the previous problem, he is only given the triangles are similar. Therefore, there is no need for the proving similarity. Here, he is not given similarity. Therefore, we have proved the triangles are similar. Once the triangles are similar, I can apply theorem. What is the theorem? Area of triangle AOB by area of triangle COD is equal to the ratio of areas of similar triangles is equal to square of the ratios of their corresponding sides. There are three pairs of corresponding sides. One is AO, first two, AO by CO whole square. The next is second and third, that is OB by OD whole square. First and last, AB by CD whole square. This is application of the theorem. Ratio of areas of similar triangles is equal to square of the ratio of their corresponding sides. Now, three pairs are there. I select this. Reason is, he is given the value of these two. He is given the relationship between these two. He is not mentioned anything about these two. Therefore, the last one and this one is related. Area of triangle AOB. He wants the ratio of the areas. Therefore, I taken the area of triangle COD. Then I select the last one because he is given the some sort of relation between AB and CD. This is the relation I picked. Now I wanted to substitute. Simple substitution. What is he given? AB is equal to 2CD. In the place of AB, I write 2CD. In the place of AB, what I write? AB, in the place of AB, I write 2CD because he is given. AB is equal to 2CD. Then area of triangle AOB by area of triangle COD is equal to, in the place of AB, I write 2CD by CD whole square. Now I have got two methods. One is I square and cancel, or cancel and square. Both are same. I can cancel CD and CD. CD ones are 1. Then what is left here? 1. This is 2, this is 1. Therefore, area of triangle AOB by area of triangle COD is equal to 2 by 1 whole square. 2 by 1 whole square. Why 2 by 1 whole square? CD cancel. This is 2 and this is nothing is there means 1. 2 by 1 whole square is square. Let's square it. It becomes 4 by 1. Becomes what? 4 by 1. 2 square is 4, 1 square is 1. Therefore, he was the ratio. Therefore, area of triangle AOB is to, ratio no? Is to area of triangle COD is equal to, this is to this, is equal to this is to this. That is 4:1. 4:1. That is the answer of this particular problem. Very important problem. Many number of times they are given in the public examination. There are two different types of problems in this particular same type of arrangement of problem. I repeat the problem once again. The problem is like this. Diagonals of a trapezium ABCD with AB parallel to BC intersect each other at the point O. If AB is equal to 2CD, find the ratio of the areas of the triangles AOB and COD. The major skill is writing the diagram. The diagram of trapezium. I written a diagram of trapezium. While naming, you should be very cautious. Why? Because he is given AB is equal to 2CD. Therefore, AB should be longer than the CD. Name it like this, AB, CD. And diagonals intersect at O. We have to find the ratio of the areas of the triangle AOB and triangle COD. First, prove that triangle AOB, triangle COD are similar. Once they are similar, we can apply the theorem. The ratio of areas of similar triangles is equal to square of the ratios of their corresponding sides. Then substitute. Three ratios you get. You select only one. Which one? What is given in the data. Data they are given the relationship between AB and CD. I selected AB and CD. In the place of AB I written 2CD. Cancel 2CD. It becomes 2 by 1 whole square. 2 by 1 whole square is 1 by 4. Some people may do square then cancel. That is 2CD becomes 4CD square divided by CD square. Cancel CD square, you get 4 by 1. The area of triangle AOB is to area of triangle COD is equal to 4:1. This problem can be slightly modified. See the problem. Suppose if this problem is modified, if AB is equal to 3CD, 3. If AB is equal to 2CD, it becomes 4:1. If AB is equal to 3CD, it becomes 9:1 because 3 square is 9. That type of problem also came for the public examination. That becomes the application of this particular problem. Number 3. In this problem, he is given a figure. In the figure, ABC and DBC are two triangles on the same base BC. See here. This is the diagram is given. In the figure, ABC and DBC are the two triangles on the same base BC. We have to consider BC as the base. Same base BC. This is the base. See, for ABC, BC is the base. For DBC, BC is the base. If AD intersects at O, show that area of triangle ABC by area of triangle DBC is equal to AO into DO. See, this problem is application type of problem because there is a slight construction is there. What we can do is, see here, both the triangles on the same base, we have to find the ratio of their areas. First I go for the regular method of finding the area. Regular method of finding the area means what? Regular method of finding area means area of a triangle is equal to half into base into height. Here height is not given, base is given, BC is the base. Height is not given, therefore I write the altitudes. See, the first is I draw AM perpendicular to BC and AM is the altitude of the triangle ABC. Similarly, I draw the perpendicular from what is known as D. From D, I draw the perpendicular, that is N. DN is drawn perpendicular to BC, therefore DN is the altitude of the triangle DBC. Using that I find the area first. Therefore what will I draw? Why I wanted to draw perpendiculars? Because the area of a triangle is equal to half into base into height. Draw AM and DN perpendicular to BC. Why BC? BC is the base. Therefore, the first part is area of triangle ABC by area of triangle DBC is equal to, I write, half into base. Which is the base? Is given. Base is BC. And height, altitude, I only drawn in the construction, that is AM. Then area of triangle DBC half into, which is the base? The base of DBC is also BC. And altitude is DN. Now what happens? I can cancel some other things. I can cancel half. Base is also same, BC cancel. Then what I draw back as area of triangle ABC by area of triangle DBC is equal to, I got AM by DN. This is my result. But he wants something else. He wants AO by DO. What I got? I got AM by DN. Then I should find the relationship between AO and AM and DO and DN. To find the relation between AM and DN with AO and DO, identify the triangles here. Now come back to the diagram. Here AM is there, here AO is there. With respect to AM and AO, there is a triangle. With respect to DO and DN, there is a triangle. These two are the triangles. Now it is our duty to prove these two triangles are similar. How I can prove that these two triangles are similar? Very simple it is. We can easily prove these two triangles are similar. Why? Because, see here, angle O is equal to angle O. Angle O is equal to angle O, vertically opposite angles. And angle M is equal to angle N because they are 90 degrees perpendiculars. Two angles are equal, therefore the triangles are similar. Now I prove that these two triangles are similar. Now you have to think that why I selected those two triangles? Because I wanted to have a relationship between AM and AO. Identify the triangle in which AO and AM are the sides. Identify the triangle where DN and DO are the sides. Two triangles I identified. Now after identification, I am proving them they are similar. Now in triangle AOM and triangle DON. Angle M, AOM it is, AOB no, it is AOM. In triangle AOM and triangle DON, angle M is equal to angle N, which is equal to 90 degrees. Angle O is equal to angle O. That is what is known as vertically opposite angles. Therefore, triangle AOM similar to triangle DOM. When two triangles are similar, their corresponding sides are in the same ratio. The corresponding sides are AO by DO is equal to OM by ON, which is equal to AM by DN. AM by DN. See? AO by DO, OM by ON, AM by DN. Now see below. These ratios are equal. In the ratio, if I name this as 2 and this as 1, see, in the place of AM by DN, I can replace anything. In the place of AM by DN, I can replace AO by DO because all of them are same. Therefore, from 1 and 2, or by substituting 2 in 1. In 1 we have to substitute the value of 2. In the place of AM by DN, I write now AO by DO. Therefore, area of triangle ABC by area of triangle DBC is equal to, there it is, AM by DN. Instead of AM by DN, I write what? AO by DO. This is the required answer for me. This is the 3 marks question. If you do this, you get 3 marks. Very simple. I repeat also. See. Problem number 3. In the figure is given ABC and DBC are 2 triangles on the same base BC. Both the triangles having BC as a base. If AD intersects BC at O, it shows that these two are straight lines. At O, show that area of triangle ABC by area of triangle DBC is equal to AO by D. The diagram is given. In the diagram, he is telling that 2 triangles of the same base. We all know that to find the area of a triangle, we require altitudes. Therefore, I write altitudes, I draw altitudes, that is AM and DN. Then I substitute area of triangle ABC by area of triangle DBC is equal to half into base into height, half into base into height. Since the bases are same, I cancel them. Half is also cancelled. Then I got AM by DN. Area of triangle ABC by area of triangle DBC is equal to AM by DN. He doesn't want AM by DN. He wants AO by DO. Therefore, I select a triangle in which AM and AO are the sides. That is AOM. And I select a triangle in which DN and DO are the sides. That is DOM. Select those 2 triangles, prove them they are similar and their corresponding sides are in the same ratio. In that ratio, I get 2 things. One is AM by DN. That is, I draw it. AM by DN is same as AO by DO. Therefore, I replace AO by DO in the place of AM by DN. I get the result. Simple problem. It is 3 marks problem. Problem number 4 of this exercise. This is a rider. Fantastic problem, and this is a problem for intelligent student. Any student is able to understand the relationship between similar figures and a congruent figure. He can easily prove this particular. You have to prove it like a theorem. See, what he is telling is, if the areas of 2 similar triangles are equal, areas are equal, and they are similar triangles. If areas of 2 similar triangles are equal, prove that they are congruent. Then what is the difference between a similar triangles and a congruent triangles? In similar triangles and congruent triangles, corresponding angles are equal. In both the cases, corresponding angles are equal. In similar figures, corresponding sides are in the same ratio, whereas in the congruent figures, corresponding sides are equal. Corresponding sides and angles both are equal in the case of a congruent figures, whereas in the similar figures, only the angles are equal, but sides are proportional. Using that basic knowledge, we are going to prove this particular identity. See, this is nice it is. There are 2, diagram is not required, then also I write the diagram. See here, let us imagine 2 triangles are there. Triangle ABC and triangle DEF. See children, this is all problems going to identify or differentiate ordinary student and intelligent student. You have to understand this. See, knowledge, one has to gain the knowledge. Knowledge cannot come and sit in your brain. You have to gain the knowledge. See, these 2 are triangles. What type of triangles? They are similar triangles. Means what? Their corresponding angles are equal. That we have to understand first. Corresponding angles are equal. And one more thing is given, their areas are also equal. Area of triangle ABC is equal to the area of triangle DEF. Now we have to prove that these two triangles are not only similar, they are congruent. See, I directly apply the theorem for this. How simple derivation. It is a rider. Whenever in the classroom a student is able to solve the riders independently, he is a class 1 student. Riders has to be solved by the children only, not by the teacher. Riders are one such thing. It identifies, it distinguishes between the brilliant and an ordinary student. See here, I directly apply the what is known as the theorem. The theorem is area of triangle ABC by area of triangle, basic knowledge it is DEF. You have to apply the theorem now. Ratio of areas of similar triangles is equal to square of the ratio of their corresponding sides. This is corresponding side is AB. AB by DE, first two letter, which is equal to BC by EF, which is equal to AC by DF. Whole square, right? This is the data. This is the data because the triangles are similar. I apply the theorem. Now I pick any one because the data nothing is there. Any one ratio I pick. Area of triangle ABC by area of triangle DEF. You have to understand the beauty of mathematics here. Simple it is. Very simple trick we can prove that the similar triangle becomes a congruent triangle if areas are equal. I pick one thing. AB by DE whole square. Right? Now see, in the same statement what is given is areas are equal. He is given that areas are equal. If areas of two similar triangles are equal, therefore area of triangle ABC is equal to area of triangle DEF. It is given. Therefore, I can cancel these two. And when I cancel these two, it becomes one. Equal cancels equal. There I write, but area of triangle ABC is equal to area of triangle DEF. It is given. It is given. It is given. Therefore, these two are equal. I cancel these two. It becomes 1. 1 is equal to, now square this, AB square by DE square. AB square by DE square. Cross multiply. Therefore, DE square is equal to AB square. D square is equal to AB square. When D square is equal to AB square, DE is equal to AB. E is equal to AB. Corresponding sides are equal now. When the corresponding sides are equal, the triangles are what? The triangles are congruent. See, I have taken these two. If I taken this one and this one, similarly I take. Similarly, there is no need to take it. If I take in AB by DE whole square, then I got DE is equal to AB. Similarly, if I take BC by EF whole square, I can prove that EF is equal to BC and DF is equal to AC. Now all the three sides of the triangles are equal. Therefore, by side postulate, triangle ABC is congruent to, formerly it was similar, now it become what? Congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. You have to understand the difference between congruency and similarity. In similarity, corresponding sides are in the same ratio. In congruency, corresponding sides are equal. Since areas are equal, corresponding sides becomes equal. When the corresponding sides become equal, all the three sides are equal, therefore it should be a congruent triangle. Therefore I have to write the statement again. Therefore, if areas of similar triangles, are equal, then they are congruent. You have to remember, always you have to remember the statement. It is a right always. It is just like a theorem. We get a statement. If areas of similar triangles are equal, then they are congruent. I repeat this problem once again. It is a rider. This problem can be solved by using the idea of brilliance of geometry. What he is telling is, if the areas of two similar triangles are equal, then they are congruent. I have written two triangles, it is not required at all. There are two triangles, for the namesake I want to write, because I want ABC and D here, therefore I write them like this. Two triangles are there. In the problem they are given the data, these two triangles are similar. Since these two triangles are similar, I can write the theorem directly. The theorem is ratio of areas of similar triangles is equal to square of the ratio of their corresponding sides. Now I pick one ratio. Since areas of triangles are equal, I can cancel them. It becomes 1. I cross multiply, then I get DE is equal to AB. One pair of corresponding side equal. Similarly, if I pick these two, I can prove that EF is equal to BC. If I take these two, I can prove that DF is equal to BC. All the three sides are correspondingly, they are equal. Therefore, triangles are congruent. Then I get the statement, if the areas of similar triangles are equal, then they are congruent. Assignment 105. First question, let triangle ABC similar to triangle DEF and their areas be respectively 64 square centimeter and 121 square centimeter. If EF is equal to 15.4 centimeter, find the length of BC. Second question, let triangle ABC similar to triangle DEF and their areas be respectively 144 square centimeter and 225 square centimeter. If BC is equal to 24 centimeter, find EF. First question and second question are of same type. Third question, diagonals of a trapezium ABCD with AB parallel to DC intersect each other at the point O. If AB is equal to 2CD, find the ratio of the areas of the triangle AOB and COD. Fourth question, diagonals of a trapezium ABCD with AB parallel to DC intersect each other at the point O. If AB is equal to 3CD, find the ratio of the areas of triangle AOB and COD. Third and fourth question are of same type. Fifth one, if areas of two similar triangles are equal, then prove that they are congruent. Sixth one is the theorem. The ratio of areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Prove. Thank you.